Welcome to the Aviation Masterclass. I'm Captain Pankaj Pahil. In the world of air traffic services, regulatory precision provides the framework that keeps steel and composite from colliding at 500 knots. This session breaks down the ATS surveillance pipeline. For every topic, we will cover the operational concept, the regulatory application, and the specific DGCA exam tips. We begin with the ATS surveillance family matrix. The modern ATC toolkit rests on four primary pillars: primary surveillance radar, secondary surveillance radar, multilateration, and automatic dependent surveillance broadcast. Look at the left side of this matrix. Primary surveillance radar bounces radio waves off the metal hull. Secondary surveillance radar requires avionics. It interrogates the aircraft and an onboard transponder replies. Moving to the right side, we have the digital systems. Multilateration calculates aircraft position by measuring the time difference of arrival across ground stations. ADS-B allows the aircraft to continuously broadcast its own GPS position. The regulatory application is strict. PSR is no longer the primary tool in modern ATC. It is a supplementary backstop used when other systems fail. Conversely, SSR information can be used entirely on its own to provide separation. This is permitted only if transponder carriage is mandatory and positive aircraft identification is established. Here is your first DGCA exam alert. You must distinguish between ADS-B and ADS-C. ADS-B means broadcast. The signal goes to all receivers in range, making it the standard for high-density airspace. ADS-C stands for contract. It is point-to-point, sending data only to a specific ground station, typically used for oceanic and remote area tracking. This surveillance capability is legally useless to ATC until a highly regulated identification protocol is completed. Before an air traffic controller provides any ATS surveillance service, they must verify your radar identification and explicitly inform the pilot that identification has been established. This flowchart maps out the sequential decision-making process ATC follows. Notice the first priority at the top, checking if ADS-B is available. If ADS-B is equipped, ATC can identify you via three methods: direct recognition of the ADS-B label, transfer of identification from another sector, or compliance with the instruction to transmit ADS-B ident. If ADS-B is unavailable, the flow steps down to the yellow diamond, SSR, and MLAT. Here, identification relies on 6 distinct methods, primarily centered around assigning and recognizing discrete 4-digit transponder codes. If you are instructed to squawk ident, but the physical ident button is broken, there is a legal workaround. As detailed here, switching the transponder from on to standby and back to on is operationally and legally equivalent to squawking ident. If your transponder fails entirely, you drop to the bottom of the flowchart, the purple section for PSR identification. For PSR, ATC relies on the radar blip itself through one of 3 methods: correlating a position report over a known point, tracking a departing aircraft within 1 nautical mile of the runway end, or instructing a turn of 30 degrees or more to observe the track change. For your exams, memorize the protocol for when identification is lost. The controller must inform the pilot immediately and issue instructions to restore non-radar procedural separation. Once your identity is locked into the system, ATC can finally exert control over the aircraft's physical space through separation and speed limits. With the identification process complete, the open airspace transforms into a structured grid governed by exact mathematical tolerances. The standard ICAO horizontal radar separation minimum between identified aircraft is 5.0 nautical miles. This minimum can be reduced to 3.0 nautical miles where capabilities permit. It drops to 2.5 nautical miles for succeeding aircraft on the same final approach track within 10 miles of the runway threshold. Maintaining precise distances requires tight speed control. This diagram outlines limits below 10,000 feet. All aircraft must fly at 250 knots maximum. Look at the inner red dotted oval. Arrivals within a 15 nautical mile radius of the VOR DME are restricted to 220 knots. ATC may suspend these rules when traffic conditions permit by using the phrase "no speed restriction." For the DGCA exam, remember the terrain rule. Air traffic control service does not prevent collisions with terrain. The singular exception to this rule occurs when an IFR flight is being actively vectored by radar. In this case, the controller assumes responsibility for terrain clearance. These exact distances and speeds are the invisible safety nets that prevent catastrophe. Violating these numbers is a violation of the aircraft's operational legality. The final hurdle of the ATC encounter is altitude verification, which must be completed upon first contact. As shown in this 5-step procedure, pilots must report their altitude on initial contact. This allows ATC to cross-reference the verbal report against the digital Mode C or ADS-B readout. Legal error tolerances are plus or minus 200 feet in RVSM airspace and plus or minus 300 feet in non-RVSM airspace. If the data is within these limits, the pilot is not advised. If a discrepancy continues despite resetting the pressure setting, ATC will instruct the pilot to stop the vertical transmission using the phrase, "Stop squawk Charlie, wrong indication." There is a mandatory rule for Indian airspace. Transponders must be left on at all times within specific Indian flight information regions, regardless of whether SSR is being used for air traffic services. Memorize these 5 specific FIRs: Chennai, Delhi, Guwahati, Kolkata, and Mumbai. ATS surveillance service is formally concluded and automatically terminated when an arriving aircraft is instructed to contact the tower frequency. This linear sequence, establishing your identity, applying separation minima, verifying the altitude, and terminating service, defines the life cycle of radar control. Rigorous study is required to master these distances and procedures. Excellence in air regulations demands preparation on the ground and discipline in the air. In the modern cockpit, these procedures form the uncompromising language that prevents the global airspace system from collapsing. Internalizing these standards is the key to passing your exams and ensuring